Okay, so this is, we have two files. One is main.storyboard, and the second one is launch screen.storyboard. These two files by default generated will be generated if you select any template. Either it will be single view, or either it will be a tab, or it will be your split. Choose any one, so but you will get the storyboard. So we have seen application delegate. So how we utilize these methods, when these methods will be fired from your OS, how can we identify the state of an application by observing these methods. Now let's see how this user interface, like the storyboard, main.storyboard. And the first day I explained info.plist. So this is the file which gives the basic information regarding your application. So when you create an app, every app is generates with an info.plist file. So the plist itself is a one dictionary. If you look at all the information, or all the values are represented in a dictionary with a key value based. This is your key, and this is the type, and this is the value. So if you can see that, so this is your file: key, type, and value. The key, type, and value. Type can be a dictionary or string or something. You can utilize, you can provide any data type which supported by your plist. If you open it, we can find what are the available data types we have for this. So as I said, the info.plist, you can see your main storyboard file base name. This is the key. These keys, if you can look at, so there are many more keys. So all these keys has been given by the Apple. So we have to configure these keys when you required one specific functionality as a global for the application. If you want to give one permission for your whole application, you can add such permissions from the plist. So here I would like to use one storyboard file as an initial launching storyboard. So for that there is a key. These key names are standard. So you have to use the same key name, because that key name internally when you build your compiled or executable, so the based on this key name your OS can identify what to do with this application. So these key names are mandatory. So here if you want to use one storyboard, because we have two storyboards, I can create another storyboard file as well. But I would like to start, when you run your application, you should, your app should display one user interface. So what, which storyboard do I need to present first? So to give the priority which needs to be presented as a main, so you have to use a keyword main storyboard file base name. This is your key name. If you provide this key, so whatever the value, means whatever the storyboard name which you are applying here, so that will be your initial, so that will be your initial storyboard which launched when you run your application. Okay, so you can create one template. You can identify this keyword from your info.plist file. Okay, So let's see what the storyboard layers. So this is your window pointer. So if this is your initial window pointer, so if I drag and if I place this pointer to a specific view, so this is your view controller. So I'm keeping this as a point for this storyboard as a one view controller. So this will be my first view controller which get represented. If I run the app, let's keep on background color, fill it, now run. It's very simple. The user interface we can easily understand. So you can see the label. This is the first page. The second page is the storyboard. So the first page is launch screen.storyboard. So I placed these labels so we can see this. This is my launch page. So the first, it's took some seconds, it's not even minutes. So the first page appeared for seconds of time, so later it dismissed and it presented with main.storyboard file. So launch screen.storyboard. If a storyboard is, if you open this application, if you tap on it, just select your project or select your targets and go to the general. Here we can see that. So launch screen file. So what you specified here, that will be your initial screen. So if I want to go with main.storyboard, I can select here. Now let's run the app. If you can see the background. So previously the option is selected for launch screen. So the first page, when you run this application, the first screen is your launch screen. So when I change to main, my launch screen file itself start with main.storyboard file. So this you can control. So even your application is having two storyboards initially, a main and launch screen. So by default launch screen will be placed here. If you want to change that, you can change it. So if you want to give something by your customized storyboard, you can create another file, you can add it, so you can see that. So this way the which screen needs to be presented first you can specify, so from this option as well. So by default, and info.plist specifies you which storyboard will be the first storyboard, so that you can identify. So let's see. When you run your application, this is your window pointer. Storyboard, we call this as like your storyboard entry point. So if I have more than so this I will tell you what exact it was. So this is your graphical panel through which you can select any graphical element. So now I have two pages. This is one page and this is one page. So I can move this pointer to which screen. If I move this pointer to another screen, then it will start. I want to move this. Yes, I would like to present this screen as my initial screen. Yes, if I change my pointer with a drag and drop, I can change my initial screen. Now you can see my initial screen is this white page. I hope you can understand. So this storyboard entry point, if the storyboard entry point is start with like whatever the screen is started with this storyboard entry point, that screen will be your initial screen. So that we have to keep in our mind. So how can we identify which screen is our initial screen for the storyboard? So whatever this screen is pointed as the storyboard entry point, that will be your initial screen which get launched if you run the application. And you can identify what is my main storyboard. So whatever the name you mention here as a value for the key main storyboard file base name, that will be your main storyboard. Is there any confusion here? Just delete this. Will not required, because for your understanding I explained this. Select and delete. This is your file, I can say. So this is your initial screen. Now you can run it. So every application is having a, so let's come to this. You can get your window. So every app is pointed with window. If we can look into this storyboard, this is having one view. I changed this color. Let's keep it. Mm, 26. This is your default color. So every application, if you want, there is a window. So every app starts with a window. If I don't want main storyboard, the storyboard will be placed on your window. So by default, with present Xcode 7.0, or if you go for 6.2, so these Xcode generating a templates. Each templates inbuilt is coming with one window. So we cannot see here the window, but still if you can look your app delegate.h file, so there is a property inbuilt is defined called window. So let me change this color. So since it is a graphical element, I have certain properties which I can utilize to apply some colors. It's a property used with the self object. Now you can see, yes, I applied a red color for the window. So you can see that. This storyboard, let's apply this different color. Now let's see which color will be visible on the screen. So your storyboard, let me remove this storyboard. I can remove it. Yeah. Now clean it. Go to your project and remove from here as well. Now my launch screen file displaying nothing, but still I can, now you can see. Okay, now clean the build, product, and clean. So the earlier instance has been cleaned. Now we started the application, but your visible interface is black. So we removed our reference from the plist and from your targets. So now you can see a window. Now the window color is, now is it like a black application level? It's a completely black. There is no user interface attached now. So even if I give something color, now there is no window on your app. It's like there is no window as of now. So if you attach a storyboard, the storyboard inbuilt comes with one window. Now if I let me add it, let me add main storyboard file base name, give your main. So this is your storyboard name. Now run it. Now you will get your storyboard, and with a different like it is sync to 6s plus, but it is giving some display, the design display, which is different. Now go to this and make this, select this view controller, go for it, put it in FRAD, and it will apply for all the sizes. Still it is displaying 6 plus. Keep the launching as a main storyboard, clean the build and run it. Now you can see your full screen of iPhone 6 is full fit. It's like your storyboard view has fit for your device. So this is my point. Inbuilt it starts with. So every application is initially the storyboard. If you start with the storyboard will have one window. So if you go for your application, that is your basic. If this is your screen will have a layer window on top of it. So on top of the window, if you use any, for example, new blank. So this will be your iPhone. Let's say this will be your iPhone device, or iPhone or iPad. And if I take something, and this will be my window on top of it. This will be my window. This is my device. So on top of the window, so there will be your storyboard. Now it comes storyboard. I'm saying it's like layer, how the layer has been presented. Whatever you present, this is will be your basic thing, storyboard, window, and your app. Um, so this is the way, like you can see, observe the different layers. This is your app layer, and top of the window the storyboard. Either storyboard, if it is launch, the launch will come initially, or else if you present another storyboard, it will come your main storyboard. So as I said, so all will be on layer by layer. Main storyboard, launch, window, and your app. So this is your screen. So your screen is on top of your screen. The first view will be your UI window. On top of the window, you can present one storyboard. So that will be the hierarchy of a user interface which presented on your iPhone. So any app will follow the same.
Suresh,
Yeah,
can you repeat that screen layers one more time, please?
it's like this will be your screen. So either your iPhone or iPad, whatever it is, this will be your screen, app level. On top of it, you will have a window as a base. So on top of the window, you can present any of the storyboard. By default, the storyboard comes with the window. So your application is comes with window, and window will have a storyboard. Without window, you cannot present anything. So if there is no window, there is no user interface, because when the Xcode is updated for 6.0 and above, so directly it's generating with a storyboard, and that if you run any app, so it runs from the storyboard. But in earlier, when we don't have a storyboards, so we have to create an application by adding a window, and on top of it you can add one view controller. But now, so these two steps as auto generated, like adding window with a storyboard. So the app itself is coming with window. Because of that reason, we can see a window property in your app delegate.h file. Okay, so just keep in mind how your hierarchy was there on your app. If you run your app, you can find your screen. On top of the screen, there will be window with a storyboard. The final and is a major point is without window there is no app. That we have to understand here. If there is no window, there is no app. So window is the one graphical element. So window will be your UI window. Every application will be presented with a window. Only UI window object can be added to the application directly. If you create one application instance like UI application subclass or UI application delegate subclass, here is app delegate will be instantiated when you run your application. Whenever this application is got an instance, that instance will be presented with a graphical user interface. So all the graphical user interface is embedded in UI window. So simply we can say UI window object will be the initial and first object on your application. So this is your root. For all graphical elements, the root is UI window that we can specify, because basically if you look at the PNG, as I said, this is UI responder. So the UI responder will starts with UI application. So the UI application will have different classes. The UI view will have a one more class like UI window. But the power of UI window is this is only the class which can represent your graphical elements. Just keep in mind UI window object can be added to the application directly. UI window API class will be used to present graphical user interface on the app, and it is a subclass for a UI view API class, but the power which UI view is not having, the UI window is having, that is only the presentation of GUI on application. So object creation for a window, it's a normal UI window, UI window, alloc init. So you can use it. So this is the same way you can do it. In the present auto generated application, inbuilt is having this graphical element with storyboard. So because of that reason, we have not initialized or we have not created any object for UI window. So we can how can we present a UI window? So UI window will be presented by using a method make key and visible. Let's see, there is a one step. Go to this and remove this. Now launch screen file, or what is this? Remove this launch screen and remove this main storyboard. So I removed the activity. Now there is nothing is presented on top. Now run it. So your application, your app is started successfully, means the app instance has been created, but there is no window, so we are not able to present any graphical user interface to the user. So as I said, you can use a window object. Let's create this window. Let me check whether it is having memory or not. If there is no memory for an object, it will be nil. Let's check. No window object in memory. If this get executed, we can say there is no window on the app. Yeah, there is no window object, so the window object is not there, so we are not able to see any graphical user interface. As I said, create a window memory for UI window, alloc init. So this initializes. Now you have to get a screen size. What is your screen size? So for that there is one API, UI screen. Let's create a screen object. So this UI screen, if you can get a main screen. If you call a main screen method on a UI screen, it returns an object which can refer your device screen. So if you run an iPhone 6, it gives the object iPhone 6 screen. If you run the same app in iPhone 5, you will get iPhone 5 screen object. It means the current screen object you can create if you call a main screen message on UI screen class. So I got the screen object. Now, so I told you yesterday, every graphical element class, if you want to present an iPhone, it should be placed in a coordinate system. So I told you that if it is iPhone, where is the origin? Origin starts at your left top corner, and you have to start at some point. If you see in iPhone 3G, your origin for your iPhone is 00. It will start at here. This will be your points. 220. This is like iPhone 5s. This screen. So you can this is the points. If it is iPhone less than iPhone 4s, we have 320 by 480. 5s we have 320 by 568. iPad we have initially 768 by 1024. So you can find the more details about what's the dimension of a device in points and pixels. I explained. So if I want to present one UI window object on my application, so if I want to present my UI window, the first step I have to create a memory for UI window graphical element. So I have done that. So now the second configuration which I have to do, I needs to give one frame. So in my coordinate system, on which position do I need to place my graphical object and what's the size. I have to pass two arguments. One is size and second one is my position. So that the object graphical element will be created on your app. So this is my window. So window will have one property called frame. So I told you that when we create one class, so the class is having a properties and actions. So the combination of properties and actions, we call it like a class. Similarly, the window class is designed to present some graphical user interface on top of the application. That is the major objective to create this window class. So for this window, I allocated memory and we allocated and initialized the object. Now I want to capture my screen dynamically based on irrespective of the device. So for that, I can use UI screen API class from UI kit. If I call main screen method, I can get the screen object. Now there is a property the window is having frame. So frame is a property which has two structures. One is origin and the second one is the size. So the combination will call as CG rect. So it will have the frame is will have one structure that is called CG rect. So you have to specify your rectangle. So the rectangle, the first two arguments refers your origin x and y. The second two arguments refers the width and height of the specific graphical elements. We have to pass these values. So I want to make sure this app should work for every device. So I capture my screen object. So whatever the screen is presents a frame, I would like to give that frame. So whatever the screen area, so I'm capturing a rectangle frame which occupied by the screen. I'm assigning the same size to the window. So and after that I used another property called background color. So this property can have a color value. So in Objective C, if you want to add some color on your UI elements, we have to use a class UI color. So this API class is designed to add some colors for your graphical elements. So this class is having certain class methods which gives you this a color. So I used blue color, so I can get a blue color. So that will be rendered for this object. So I'm adding that my window dot background color property is equal to, I'm giving the value of a blue color. So this window object will be rendered with a blue color. So now as of now it is fine. I initialized, that is my first step. The second step, I specified the origin and my size for the graphical element. The third, which I want to add, it's optional. If you want to give a background color, we can provide. If you don't want, so still it comes with a white color. So by default every graphical element will be rendered with like it will have a white color. So white colored objects. If you want to add any, like if you want to render some different color, you can assign to background color property. So it's filled the graphical elements background with the same color whatever you assign. So this is my optional, but still I added one blue color. Now the last point is I would like to add this window on my app. So in order to add this window, for example, now let's run this. So it is saying that there is no window object in memory. So when there is no window object in memory, I initialized my window with a memory allocation. I captured the screen object and I provided my screen size to window size, and later I filled my window color to background color as a blue color. But still we not able to see that. We were not able to see the window on my app. So what we missed, we have not added this window object for the application. Now we need to present this window for the app on top of the app. So for this, the window is having one method that is called make key invisible. So if you call this message on your window object, so your application can present that window. But let's see, there is something, it's crashed. Terminal due to uncaught exception, internet there is an application windows are expected to have root view. Okay. So I have the window memory. So I have a screen. Let's go to this. My window is also having that, but it's got crashed. But I'm not able to see that. So it is saying the window should be comes with one view controller. So window alone is not accepted. It required one root. Hmm. App launch should have it. So we have a one more controller. Let's create this. We'll see. So I want to use this controller as well. Create it and allocate a memory. So this our steps as graphical steps wise, it's very common. Let me create alloc initialize the memory for this object. Now I want to pass this as my root controller for the window. Let me present this. Now we'll see. Will it throw an exception or will it present our graphical user interface? Now you can see a window with the color I given you blue color. Let's make it to yellow color. This is your window, but still it's not having edges or filled. It's not fully filled. So this is where like you can present. So the window creation, and we have done an earlier like if it is Xcodes 5 and 4, and in that cases we added this window. But you can observe from here, if there is no window on your app, there is no user interface. That's what I would like to explain you. So you can observe here, if there is no window, you can assume that there is no user interface on the app. So this whole process comes with storyboard. If you add one storyboard, the storyboard inbuilt will have a window object, then it will take care about a window and as well as one user interface element, like one view element on top of the window. So if we look at initially, we presented a window on top of the app without adding any other graphical elements. So we got an exception. We ended with an exception saying that there is no root controller for your window. So we created another object for one view and added that view as a property for the window. So this is the base. If you can understand, so one app should have a window with one view controller. Just keep in mind, if your application is running with one good user interface, it means that your app is having a window. On top of the window there is one view controller. So if it is add comes with the storyboard inbuilt having this structure. So that we have to understand here. So this is your earlier, for your understanding I explained this. So simply you can go with your info.plist, and whatever comes, click on plus button, and there is main storyboard file based name. Give this key and add the value, whatever your storyboard which you would like to present, give that. Here my storyboard is main. I used main. Now you can see I want to run something. So you can run your user interface. So your app looks like this if the app is having one storyboard. So since the window, on top of window there is a view controller, so if I apply some color on my view controller, so it will be presented. So or else I want to remove, I would like to make this the presented view as a transparent. My background was I would like to make this as a transparent. You can keep it transparent. Now I want to apply color to window, so you can give this. Now you can see the window. So here you have to, you should understand like what is top, what is second, what is third, how the layer structure, how the layers got structured. So we can understand from here, from this demo. Your app, on top of the ant there is a window, on top of the window there is a view. So that will be your hierarchy: app, window, view controller, or else anything. So this will be your base structure of your user interface. So let's see that. So how it is here, we can see the 2 points, the frame and bounds. So let me explain you. So this is one of the interview question. So what's the difference between a frame and view? So just keep in mind, when you work with user elements, graphical elements, every graphical element should have one memory, and later it should have one frame or some origin or position. It should have some frame, so that then only it can present some interface for us. Because if the size is 0 0, then we cannot see that. So it should have some specific width and height, so that we can able to see what you rendered on the with that graphical elements. So as is suggested, it should start with one origin and it should have some width and height. So based on that, it will be rendered, it will be rendered based on your size and origin. Origin specifies where to start. So your every iOS application origin is left topmost, it starts with 0 0. If I said my frame of a window is 0 0 and 100 by 100, then it will start from here. And if I say, if I 0 0, then it will start from 0 0. If I specify some height is like 200 by 200, then you can see something like this. Your screen will looks like your window will be added on your phone on this specific location. Means whatever the view, if you specify a frame 0 0 and 27 by 21, so you can see one object something like this. Whatever the selected area which is specified, you can see that. If I specify some origin position in different location, so here let's see, this is my origin. I can place one graphical element at anywhere on my screen based on the origin. So the frame here, you can look at two things. So graphical object should have a memory, it should be allowed and initialized, and later it has certain properties. The one property is related to your size and origin. The size and origin is mandatory for any of the graphical elements, because the origin specifies where to start with respect to the super, and size specifies what's the area which that graphical elements is occupying. So this is 0 0 and it's having some width and some height. The internal area called as bounds. So we use two terms here. When I assign the frame and the size of a screen to window, so I captured bounds for screen and attached as a frame for window. So here both are rectangles. So rectangle, there is a CG rect make is one of the structure which defined in a core graphics framework. So because the framework, it starts with a core graphics, so all the elements in core graphics starts with CG rect, CG point, and CG size, something like that. So here we can see two properties, one is frame and one is bounds. Bounds is always specifies the self area of the object. This is my object. Whatever the area is occupied, the whole area is represented as a bounds. Bounds always calculated inside of the frame. This is 0 0 always. If I talk about bounds of this 0 0 with some size and height. If I talk about a frame of this object, the frame origin will be calculated with respect to the super. So this is my super, green view is my super. For this super view, where this is started, this is started 100 pixel from x and 50 pixel from y. So my origin is 150. 150, if it is 100 by 100, we can say 150, 100, 100. That is your frame for this view. So frame is always talk about frame always gives the details related to the frame always gives the details. So as I said, there are two elements. Frame. This is one of the interview question. Frame A frame is a combination of an origin and size. Origin will be calculated by its super view on where it is added. It means it's one of the rectangular area. We can say that it is a rectangular area, but the area of origin is from different. If it is bounds, it's a property. It is a area. It is area inside of the frame. It is a self area. If I say self area, always origin is 0 0 and will have some size. The size will be the width and height. So it's always refers to the self. The frame will be calculated from the super where it's located. The bounds will be calculated by self itself. So if I say frame of this view, it starts from 150, 100 by 100. If I say bounds, bounds is always 0 0, 100 by 100. If I say the frame of this view will be 10 10, my origin position something like 100 by 200, 100 width and 200 height. If I say bounds 0 0 and 100 by 200. So if this is my screen origin is 0 0 and here the bounds is also 0 0. So if I say the frame and bounds of this green view, the green view frame is 10 10, but the bounds is 0 0. The origin I am saying bounds origin is 0 0 and frame origin is 10 by 10. So frame will calculate and based on the super view, bounds calculate by itself. I hope this point will be clear. So because the frame and bounds, we should know the difference. That is one of the question in your interviews. It's a basic question. So this is about a window and how you can present a graphical element. So every class, all graphical elements here, if you can say like window and all is subclasses of your UI view. UI application is a subclass of UI responder. So the UI view is a subclass of UI responder. The UI window is a subclass of UI view. But the window is having one powerful feature is it can present a graphical user interface directly to the application, which no object can do that. So the storyboard inbuilt comes with a window. So if you create any storyboard, the storyboard inbuilt have one window and with one view controller. So we'll talk about view controller, what it is in later classes. So view, this is a view. We can see that because window you can see how exactly the screen is presented. So this is your application user interface invocation, how the user interface will get executed. So this is your start. The user can tap on the app. It fires main method. From there it comes to your app launch. So window will be presented, and on top of the window it can able to accept all the user events. So this is a basic just keep in mind what can be your layer of the applications, layer of views on your app. So this is your screen size and positions. Why you needs to take a screen? Because the screen is different from US. Screen is the one class which can give you the screen dimensions irrespective of the device. Because if you run the app in iPhone 6, the screen object will give you iPhone 6 dimensions. If you run the same app on iPhone 5, the screen object will give you the properties related to iPhone 5, because based on the device it gives you their specific like details. So let's come for UI view. I hope it is clear with what UI window, why UI window is mandatory for an app, why this UI window property by default added to your application app delegate, because that is where the importance the window is having in your Xcode basic iOS templates. There is no window, there is no graphical user interface. That directly we can say. So this is the app. Mm. So info.plist just we played with one key value. So mostly we can understand what's the import of a info.plist file. So how we can utilize. So I explained with one property. So in coming classes, we see how these key value pairs will give you the features for your app, how these key value pairs will improve the features of your app. So this is, let's come to the views. Go to this storyboard. So we started with UI responder. From the UI responder to UI application. So UI application I explained yesterday, UI application delegate lifecycle. So in this UI view, we have seen one subclass of UI window. So I told you the basic principles of a graphical object. The graphical object should have a memory and should have a frame. I mean frame in the sense it should have some size and origin and size, and if required. So and the third property is like it needs to be added to some other view. If you add, then only it will be presented. If we won't add a graphical object to a window or any other graphical object which is added on window, so that graphical object won't be visible. If you want to make one graphical object visible to the user, it needs to be added to application. So that we should keep on 3 points: memory allocation, and like the size and the position of the object, and the adding the object to one of the other graphical object which is visible on the screen, so that we can able to see that graphical element by the application. Means like from app we can see that. So here every object, like let's see what UI view, what UI view is like. We have seen the window usage. Let's see the UI view usage. So I can create one UI view. Let's remove this yellow color to white color. Let me create one UI view. So the difference for a window and view, the window is a subclass of UI view, but it is having a feature. It can present a graphical representation on app, but view can't do that because the view is not configured, because we cannot directly add a view to application. We need a window support. So let's create one view object. So alloc as memory allocation, as I said, this is our first principle to initialize allocation of object. The next principle should be created a frame. Later we'll talk about how to eliminate the frames and all. First understand the base concept. It should have one size. So all like cg rect, here if you see there is a one C language method we call here. It's like a cg rect make. The first initial two characters are cz. So it is taken from the core graphics framework. How UI view, these UI2 keywords can represent this API is from UIKit. Here CG rect make, first two characters CG represents, it's related to core graphics framework. Because in some of the JDs we can see the core graphics is mandatory and Cocoa Touch is mandatory, UIKit is mandatory. So if you work with CG rect or some these kind of functions, you can make yourself you worked on core graphics. So let me present my origin is 100, y position is 50. I would like to give some width is 100 and x is height is 100. This is my origin and position. Now let me fill my color view color with the help of background color property. Give some color is red color. Now I have to add this to window. So there is a method. Every view is having one method that is called add subview. Let's add it. Let's see. Now we can see a graphical element, a view which filled with a red color and placed by based on your frame details. I presented with 150. So from x-axis is 100, from y-axis is 50. This is your point. Origin starts at 150 and width followed by 100 and height followed by 100. You can see the 100 by 100 width and size. In size 100 by 100, the origin is 150. So this will be your graphical element. I added this graphical element to window, so we can see this window, this object visible on window. If there is, if I comment this method, there is no view is attached for window. You can't see that. So my first 2 points, allocation and frame. My third point is adding. If you want to fill a color, that we can apply, it's optional. So every view having some certain features like properties. Background color, you can fill with a color, and you can specify brightness, whether you want 100% brightness or you would like to reduce, so that we can do it. And you can make it visible or invisible. You can hide a one graphical element, we have a property. And you can give a user interaction enabled or disabled, because since UI view is a subclass of UI responder, it can observe and identify the user events. If I tap on this view, so there are certain methods which can recognize this gesture. Any gesture if you apply on view, we can observe it. We have that methods since it is a subclass of UI responder. If I want to remove all these observers, then I can make this user interaction disable. I can disable that. There is also such kind of properties are available for view. And the content, there are certain properties like how the content needs to be filled within this frame. So either it needs to be filled or either needs to be aspect to fit, how exactly you would like to present a content on a view. Because the window, on top of the window I added a view as a sub. This is a sub view, this is a super view. If I get a bounce, bounce will be 0 0 100 100. If I want frame of this view, it will be super is window, on top of the window 100x pixel and 50y pixel, 150 and 100 100, that is my frame. And there is a center. So there is a property called center. If I use that center property, it gives the center point of this view. Here this is 100 100, I can get a center point. So see here, the center point is related to your super view. It's not related to the present view. It's related to the super view. If this is presented at some point, so then it will give you that center point. So I can get the center as well. So let's say point center view 1 dot center. I can get some point like what is the center point, because the CG, if I apply CG means the property like that structure is taken from core graphics. Now you can see what is the center position. 150 100, because 100 50 is 50 50. From x-axis is 100 is already there. 100 plus half of the size is 50, 150x, and this is 50y, and this is 100 will be 50. You can say 150 150 100 will be your center of the view. Center here, if the property center gives you a value, the center related to the super view. The view is added at some position of window, but if I ask the center, it gives the center related to the super view. So if you change the center, like it's very easy if you move something on with the center, that I will explain you how these animations works. So if I want another view needs to be added, I can present another view. Let's give it a different name and apply. Green color. If I give the same color, it will override. Now it's overridden. Let's bring one to front. So I want to see the view one. So there is a method from view, bring subview to front. Now my view which having a red color will comes front, because since both are occupying the same memory, like a same location. So that I can change it by keeping it 300. Now you can see both. So you can keep it 200. So now this is not required. Earlier I used, because both frames are same. So one frame is hiding and another frame. So I want to bring the last one to front, so I can use it. If I want to send the first one to last, that is also I can do that. So this is my 100. Now one top of another. So the view 1 2 is hides this view. So I want the first view on top. So I can use the method. So it brings. Now I would like to send this to back again. I can send in a view hierarchy. I would like to send one view as a back in the sense it will go for as a first element. Now you can see. So this is where like you can bring one object to front and you can send one object from front to back, because internally background a subview will maintains one array. So when you add it, it will add in the same sequence. Whatever it's added last, that will be presented on top if all are having same frame positions. So you can swap it from last location to first location or wherever you want. So based on that we can see the result. So this is where like you can create one graphical element and you can add it on another graphical element that will be filled with some color, and that can be added with some different size and height and with a different origin. And this is where like to the way of creating a graphical element. So we have the more concepts. Still the view we can create a customized view, because if I make sure that now even if I send bring back and something, now that doesn't make sense. Now this is, you can see the two elements. I can present one view inside another view. If I want, I can present So this is my view 2. I can add this on view 1. So now the view 2 is a subclass for view 1. Let's specify 10 and 10, 30 by 30. Now you can see view 2 is a sub 1. You can add it something like this. So if I hide this view 1, it hides both. I can hide this. So there is a property called hidden. If I send the value as s, it will be hidden. Now there is no red view. Since the red view is hidden, the yellow is also got hidden, because the yellow is a sub of red view. So you can see the certain properties. Go to this UI view.h. You can see the properties. User interaction enabled, tag and layer class, frame, bounds, center, and there is an animation, touch enabled, and we can see there are certain methods as well. You can see the size and the auto resizing mask, and size to fit, super view. You can get a super view, get to know all the subviews of array, and window object on which the view is added, and you can do like removing and so you can, there are certain methods you can see, and there are also certain properties also you can see from this UI view.h file. This is your class like .h file. So from where you can learn what kind of properties the class is having, what kind of actions the class is having. If I want to hidden, then I can hidden. So I don't want to hide, so I would like to remove from its. So now I want to remove this view or remove from super view. So it's like when you remove, it will be removed from the super object, and it will be removed from the memory as well. So if you hide, the object will still be there in memory. So if you remove, the object will be removed from the hierarchy as well as removed from the memory. So this is what like your UI view, and still we can the UI view itself is having some certain life cycle methods that we can do. That I can create a subclass for a UI view. How I create NS object? You can create a subclass, customizer class, view custom, create. Now whatever I wanted here, I would like to do the same thing on my view. That's it. Like, let's remove it and come to this. So there is a method, you can see direct. You can use this method to do some drawings if I want. So I'm saying that. So let's see, self. Here the self represents current view. Now let's come to this and import this view. Instead of this view 1, let's create a view 1. Alloc init with frame. So you can use directly. This is also either init latter frame you can do. So you can specify in any way. So just add it. Just comment this. The view 1 custom. So is it added to the window? No, it is not added, so we are not able to see. Sub.window add subview view 1. Now you can see that the background I have not specified for this object. So I have not specified, so I got my background color, UI color. So whatever the color, like UI color is my API class. which gives you my color object. So you can see that. So this is this is like it's a purple color, so itself the view is having a different subviews. If you go to this, the view itself is having two objects, so the two objects are presented on the same view custom. Still it is having certain life cycle methods, so that I will explain you tomorrow what is the view life cycle methods. I hope you understand how to create one graphical object and how to render with a different color and how to add it to another view. How can we present one graphical object on